people learn things from dreams. Like for real, a lot of advancements have been made by a scientist having a dream or an intuition or something. And that's happened for me too with fungi, where, yeah, when I first started working with fungi, I dreamt about them all the time.
I'm here today with Dr. Danielle Stevenson. Danielle, thank you for being here.
My pleasure. Thanks for having me.
Let's start at the start. Who are you and what is your background?
That's such a simple question that's always hard to answer. I guess I'm a multidisciplinary scientist. Mostly I work with fungi and soil, plants and people, mostly around cleaning up pollution and stuff like that. But I also intersect with the arts and social sciences and humanities too.
Amazing.
Yeah.
I want to start with the problem area that you spend a lot of time researching, which is pollution. Because I think a lot of people hear about pollution and they think they have pretty good understanding of it. But from what I've read from your work and in some past conversations, there are some details you can provide that really paint the picture.
Sure, absolutely. I'd like to start with just a kind of like an origin story that's personal. So I grew up in a really polluted place and, across from Detroit, where the auto industry and all industrial agriculture, a lot of industry there. And everyone, was working with or connected to these industries. And Lake Erie was super polluted. So I grew up in this very polluted place, seeing both the linkages between environmental pollution and public health and the economy. And when the auto industry kind of crashed, the whole area went into recession. A lot of these industrial factories shut down. And I also kind of grew up seeing nature taking back. So mushrooms, plants growing like around oil refineries that were abandoned and things like that. So this really informed from an early age my curiosity and also concern around pollution, and then also like seeing how we can address pollution by working with nature. So yeah, where I grew up was a cancer alley and this sort of hotspot, but the problem isn't just localized in specific areas, right? So in California, about 1/10 of the landmass is contaminated, and that's just the sites that are regulated by the Environmental Protection Agency. So a massive amount of land, more than we even know, is polluted.
And how much of the land is regulated? Ballpark.
Well, about 1/10. So in California, about
okay. So you're saying
by area.
all of the land that the EPA all the land that the EPA regulates is polluted, is what you're saying.
Mm-hmm.
Wow.
Yeah.
Okay.
And so that's a lot, and there's a lot more. I think in LA, there's something like 500. I don't know the area, but there's contaminated sites everywhere around LA County, and so it's a huge problem. It's not just the land that's contaminated. Our water is contaminated too. The air is, there's air pollution here, famously. So, the problem is very large. It's not just, sites of industry or past industry that can be contaminated. There's also a lot of waste that we produce that is toxic as well. So, it's a huge problem, and we need to address it. But it's just not something that I don't know. I don't hear the problem being shared or framed in terms of how big a scale is. And so is it sort of, this is a really pop culture reference, but there was that film Don't Look Up. So sometimes I like to say it's kind of like a Don't Look Down situation. Like there's contaminated land everywhere and it's just not really part of the public conversation.
Do you have a guess why?
The folks responsible for the pollution don't want to be liable to pay to clean it up. So I think that's a big part of it. So there's, I think, a lot of lobbying and just avoidance by companies that have polluted. And it's pretty effective because a lot, the problem is that sites get polluted and then they just sit there. And then so much time goes by that even, trying to bring some type of legal proceeding to get, you have to go back through time and be like, hey, there was this company here in 1920. It's hard to, it's easy, I guess, for companies to then claim like, well, maybe that wasn't us. Maybe it was from air pollution, or maybe it was someone else. So I think that's a big factor why it's not part of the conversation. It's that, the folks doing the pollution, or the companies rather doing the pollution, don't want us to all chase them down and have them stop or increase regulation or pay for cleanup.
Yeah, I had read a story, and this is one of those, like, I don't remember any of the actual stats, so nobody quote me on the actual stats, but that basically, like, most or some upsetting percentage of gas stations are brownfields, because those tanks are only meant to last without leakage for like 30 years, and some insane percentage of those tanks have now started spilling oil into the soil.
Absolutely. And sometimes it's really sort of clear like that, where there wasn't foresight, and it's from, gas stations are very commonplace, but it's from a clearly linked to a polluting industry, kind of makes sense. But there's also a lot of pollution that is a little more almost like mundane. Like, for example, in agriculture, right? Agricultural lands can actually be highly polluted as well.
Oh, wow.
And it's from such a simple and kind of innocent source. Like, a lot of fertilizers and pesticides contain hazardous metals, and because they don't break down, they just build up in so we might see agricultural lands and be like, well, these are fertile, productive lands, not polluted. It's not always the case. So there's a lot of different sources that can lead to this widespread pollution. And then I think there's a lot of money in not, in keeping things the way they are.
Oof.
Yeah.
All right. Well, on to some of the work that you're doing to maybe start to address some of these harms. Could you really quickly give a quick definition of what is bioremediation and what specifically is mycoremediation?
Yeah. So bioremediation is short for biological remediation. Biological referring to living organisms. Remediation referring to resolving or correcting contamination or pollution. Or addressing contamination or pollution. So when you put those together, bioremediation is working with living organisms, plants, fungi, bacteria, worms, any living organism, to clean up contaminated environments. And mycoremediation is just working with fungi to do that cleanup. Super exciting. It's an area of bioremediation that's been overlooked, I'd say. So it's exciting that we're getting excited about it. Starting to work on it.
Before we get actually to the particulars there, why do you feel like it's been overlooked?
I think because our sort of it's interesting. So there's a bunch of mycoremediation, bioremediation happening in Europe and in China and in other parts of the world that they're mushroom loving cultures. Like, mushrooms have always been a part of their cuisine, medicine, whatever. So I think there was less resistance, but here in North America, there was just a lot of fear and misunderstanding about fungi in general. And I think that limited, it took us longer to get through that, to actually look at the applications for fungi.
Got it. Do you feel like, this is maybe like an aside to the main point, but do you feel like, documentaries like Fantastic Fungi are popularizing the types of work that you're excited to see happen? Because I know that a lot of people in the psychedelic community are very excited by that forward momentum. But from the research and scientific standpoint, how is this communication with sort of mainstream culture impacting how interested people are in mycoremediation or sort of exploring new use cases like that?
Yeah, it's an interesting question. It's really variable. I mean, since I got into this field maybe 15 years ago, it's been really nice. When I started doing this stuff, people were like, "What are you talking? This is weird. What do you mean?" Like, it was just not like people didn't know. It wasn't as popular. So it's great that films like Fantastic Fungi and some of this more popular media is helping folks understand fungi better and all these potential beneficial applications. I remember the moment when like my parents called me and were like, "Whoa, did you know that fungi could do?" And I was like, "Yeah, that's what I've been saying." So I think that's great. These films have helped people get excited about fungi and all these other potential applications. Like, in universities, you can't really study. I mean, you can study fungi in a plant pathology program, but that's sort of a negative, right? Pathological. You're just studying fungi as pests and pathogens. So I think it's great that there's this sort of movement more popularizing beneficial fungi and beneficial applications for fungi. So I think that's great. And then, yeah, I also think that there's still a greater, now we can start to add depth and sort of nuance and complexity, right? So people are on board now. That's great. And now we can go deeper is what I'd hope. And I bring that up because with mycoremediation specifically, there tends to be a lot of misunderstanding because of, I think, some of these popular, like Among Us. Is that what it's called? No, The Last of Us.
No, The Last of Us.
I said that wrong. So I haven't given a mycoremediation talk or presentation where I haven't been asked, but like, have you seen The Last of Us? If we, introduce fungi to clean up a contaminated site, are they going to eat our building and my face? Like, are we going to all die? And so, yeah, I think there's still, now we can start to add more complexity and depth to the discussion about fungi.
It also, it relates with some of the, the Western approach to like burn the witch. Like there's a lot of, from my outsider view, it seems like there's a lot of skepticism related to some unverbalized histories. Is there any credence to that?
Yeah, I think so. I've experienced that for sure. Do you mean with mycoremediation specifically, or just the whole
fungi
field,
in
fungi
general?
Yeah. Yeah, absolutely. I think because some of the applications that we're exploring involve like, for lack of a better word, like a drug, essentially, like, psilocybin mushrooms. So that's a highly sort of stigmatized space. Mental health ties in with that, another stigmatized space. Yeah, and same with like remediation, right? Again, we're so far, some of these applications for fungi that are being popularized and explored are connected to things that we don't like to look at or talk about as a society. So, which I think is really interesting because fungi, it's sort of like there's a mirroring there of like how fungi themselves live, right? Typically underground, typically out of sight, most of their life. And what they do is, in the darkness and underground. So it's kind of interesting that their applications also, at least like sort of metaphorically, are in those same spaces of darkness and like stigma where we don't want to really look at that or talk about it. So yeah.
And I mean, even at the above ground, but on the ground level, we don't want to think about our trash. We don't want to think about where our trash goes. And, historically prior to, products that don't break down well, mycelium would be what's, recycling our trash proverbially.
Yeah, absolutely. Like at some point, some fungi learned how to produce enzymes that can break down petrochemicals, right? And that's why we don't that's essentially why we don't like fossil fuels aren't a renewable resource really, because now fungi will break down all the dead stuff that falls over. So it's not turning into, into fossil fuels.
Yeah.
Yeah.
Okay, so let's kind of zoom in on the particular microremediation work that you're doing.
Yeah. Okay. So, yeah, I guess what I've been working on are, working with different types of fungi to break down all kinds of problematic wastes. So different toxic wastes, really common wastes that clog up landfills and don't break down, as well as contaminated lands and waters to a lesser extent. And so I've been exploring this over the years in partnerships with universities and labs, through my own lab and then through my PhD work, where I really tried to fill in gaps in this field so that it can be more broadly understood and applied to actually solve these problems. And so really what I was looking at in my PhD work were one, field testing these approaches. There's, very few field studies that have been done into mycoremediation. A lot of promise shown in labs, but it's a whole different thing when like to have a fungus grow in a petri dish without any stress, competition, environmental conditions. And that it's a whole other world out there on a contaminated site where it's super toxic. It's like dry and hot, and there's tons of other organisms. And so I really wanted for this to be taken seriously and actually applied, we needed to test it on contaminated sites and see how it performs in these real conditions that it'll need to be applied. So that's been something I'm really excited about, that I worked on in my PhD, kind of continuously scaling and applying these fungi really in combination with different fungi, different plants, and then continuing to scale and test in the field and test on more sites and scale. Yeah.
Yeah, and it also reminds me, because your PhD is in environmental toxicology, right? So that even gets back to your point that to do the work, it has to be framed in the negative.
Exactly. Yeah, exactly. Yeah. And yeah, I mean, I went into environmental toxicology, my background was in like art and history and so it was a big jump, but I've been doing science. I built a lab. I'd been doing this research for over a decade and just kind of kept hitting these walls where, because I didn't have the science degree, it wasn't the work wasn't being taken seriously. So it was helpful to go into just the most intense like environmental toxicology program and, get better at science, partner with regulatory agencies and cities and try to, again, have this get into, I was like, let's be rigorous. Let's do the science. Let's do this in the scientific way with all the different folks who are affecting policy around this, all the stakeholders essentially, and try to move this field forward. But yeah, it's always kind of framed in the negative. I couldn't find an actual lab to work on this in. I was in an environmental science lab that studied metals in soils and groundwater, and then I brought in the mycology piece. And otherwise I was being kind of funneled towards like plant pathology again, or this more kind of negative like ways of understanding fungi. I was like, hey, y'all, there are beneficial fungi, like that's a thing.
Right. And they're not plants.
And they're not plants and they're not bacteria. And yeah, we don't know enough about them.
And from what you've described, it sounds like even getting to do those field tests, like getting the clearance with whomever owns that land and who's willing to essentially like admit this is a contaminated site, seems like it'd be pretty difficult.
It was almost impossible. I was told that we couldn't field test a new remediation method unless it had already been proven many times in the field. So that's impossible.
It's a literal catch-22.
Literal catch-22. And yeah, so really my hope is by partnering, with the regulatory agencies who are essentially constraining innovation in remediation, and just finally doing the studies that can now be pointed to as studies that can support further studies, So yeah, I pushed through that somehow. And I think it was because I was doing it in an academic context with a respected academic institution that it really, it was pushed through. I had to do the permitting. It was wild. Just trying to get permits to even step foot on these sites, let alone sample, let alone do remediation studies. But yeah, my hope is that this will now open space for more people to do this, and it'll be easier moving forward.
And in The Last of Us, obviously, cordyceps is the. By the way, can you pronounce it fungi and fungi?
Yeah.
Okay? Because I want to make sure I'm
Tomato,
not like.
tomato.
Okay, cool, perfect.
Yeah.
So cordyceps is the sort of much maligned fungi in The Last of Us. But when you're approaching, how do we get toxic metals out of the soil? Like, how do you begin to identify the fungi that you're going to work with, especially if you're in a field where like you have to already have proven methods that you're working from within? So walk me through a little bit of what that process is like.
Yeah, I'd love to. So the process of selecting the fungi that we're going to work with for a particular site involves one of several approaches. So one approach is to just identify the fungi that are already present. So that means that they're adapted to the conditions. They might be doing something with those contaminants anyways. So identifying them and then supporting their growth so that there can be an acceleration of what they're already doing, right? So there might be fungi there that are decomposing, so literally eating, petrochemicals. And if you give them a bit of water, a bit of wood chips, or something a little easier for them to eat, then you might be able to speed up that process. So that's one approach where you just figure out who's there and make it a little easier for them to do what they're already doing. Another approach is introducing a known, already tested, already sort of proven in other studies fungus that's known to degrade or interact with the contaminants present on a site. So that's something that I've compared in my studies is like, well, what happens when you just stimulate the fungi that are already there as compared to introducing a known remediator species. So a really common one folks listening might know about is like the oyster mushroom, right? The Plotus ostreatus. It's really aggressive fungus, not a picky eater. There's been some studies that show its capacity to degrade diesel and other petrochemicals. And so that's one that's been, you can find plenty of studies on the oyster mushroom. So that's something that we compared in some of our studies is, how does like this known remediator that we can provide study like citations for to appease the regulatory agencies and so on, compared to just stimulating the fungi that are already there. Yeah, so that's kind of and in my processes, I'll work with both of those approaches depending on. I try to always identify what's growing on site and or on similar sites in a region, and I prefer to work with those approaches for a bunch of reasons. It just tends to work better and be cheaper and easier than trying to introduce a species that isn't used to those conditions or the region or whatever, and then keep it alive and keep it happy so that it can grow and sort of compete with what's there. So I tend to favor the first approach, which also opens up space for discovery of new, previously unknown, remediator species. So I tend to try to favor that approach. But one scenario in which I will work with just whatever species, whatever fungus can do the best job is in waste scenarios. Because typically when we're cleaning up a landfill, cleaning up whatever, like a specific type of waste. We're doing that in a somewhat contained system. And so in those environments, I'll just work with whatever will gobble that stuff up the best.
And so it gobbles it up, and inevitably there's some byproducts, right? So how do you account for, like, when you're pitching this to the site, when you're pitching this to your advisor, like whoever the stakeholders are, because inevitably there's some element of the unknown with whatever byproduct will be. So what's that process like? And I understand that the Petri dish method probably is not ideal, but maybe there's a little bit of testing there to make sure that it won't add another.
Absolutely. Yeah, you have to do all of the studies, right? You need the Petri dish studies and the little greenhouse studies so that you can understand in a more controlled setting what all the variables are and what the inputs are and what the outputs are. So if we're talking about organic waste or organic contaminants like diesel and, stuff you'd find at gas stations, or even like plastic, which is made out of fossil fuels. So it's all really the same stuff on some level. The byproduct of mycoremediation is typically carbon dioxide. And so the fungus will literally, through enzymes, break it down. They'll get food out of that, and then they respire CO2 just like us. So that's not a bad. Climate change. So that's not great. But so yeah,
better than certain things.
Better than certain things. That's not always the case though. With some worrisome pollutants, sometimes the breakdown product can be another toxic thing. So there's nuance there. There's complexity there. But typically, you end up with soil. You end up with really nice soil, actually, when a fungus, like a decomposer fungus, eats, again, plastic or diesel or whatever. The byproduct is healthy soil and some CO2. But if we're talking about metals, they don't break down. Or they generally don't break down. So if we're talking about like lead, a worrisome hazardous metal, it's not going to break down. And so if you're working with fungi to bind up the metal in the soil, or you're working with the fungi that connect with plants to help the plants take up the metals into their bodies, where sites can be cleaned when those plants are then harvested, the byproduct is biomass that contains these metals. So, there's a whole opportunity there for creating circularity, and there's programs happening to then re-extract those metals, and you can reuse them and diminish the need for additional mining. There's a lot of potential with that byproduct, but if you're dealing with metals, and bioremediation, there's always going to be still metals, just in a more concentrated form, and at least the land is clean.
So what I hear you getting at is that there's this ecological approach. Like, you can't just sort of like apply fungi and like everything's solved. Is that there's inevitably going to be this like cyclical nature to movement of nutrients and living organisms in soil. So I'd love to hear you speak to that idea. And also, I know that one of the big things that people talk about is the way that mycelium will relate to plants, and in particular the roots of plants, and how that all kind of works in concert. So over to you on that.
Thank you so much for asking this question, Jesse. I love it. Yeah, I love this so much that I often will call this work eco-remediation, to refer to the fact that I'm actually mimicking nature and working with regeneration and remediation of ecosystems. So the reason I focus on fungi is because they've been overlooked, and they're essential in like every ecosystem found around the world. So I tend to highlight the fact that I'm working with multiple types of fungi, but I'm not only working with fungi, and that's because nature doesn't really do monocultures, right? We do it like in nature, you have primary, so this will track into the plants and the fungi. But so yeah, in nature, you have decomposer fungi that can literally break down rock and stuff that's really hard to break down. And as they do that, so they're they kind of start a process where they turn things that are really hard to break down into soil, essentially, that now, worms, other types of decomposers, bacteria can get in. Now they can eat too. The soil keeps getting built. Now there's nice soil that plants can grow in, right? And then you have the mycorrhizal fungi, so the fungi that are connected to plant roots, that come in and form relationships to help the plants grow. It's a trade relationship. And we can also work with all of these organisms within these systems. So again, the decomposer fungi that start processes of breaking down hard stuff could be lignin. Like in nature, it typically would be lignin, rock, stuff like that.
And what is lignin?
Thank you. That's what makes trees hard and rigid. So it's a really complex polymer. And really fungi are the best at breaking that stuff down. So yeah, we want to include in these eco-remediation projects, we want to mimic nature. And so we want to have those decomposer fungi that can break down hard stuff to break down, like petrochemicals and like all these other pollutants. They start breaking them down. So there's cleanup happening, plus they're building healthier soil. And now we have bacteria and worms coming in. We plant some seeds for plants that are especially good at pulling up metals. So again, with this, we're just mimicking nature, and we're drawing on what plants are already doing all the time, right? They're getting nutrients by pulling them up from the soil through their roots. And so folks don't know, nutrient elements like phosphorus it's a different type of element. Lead is an element. So plants can be worked with to pull up lead and hazardous metals from the soil, just as they would pull up beneficial nutrients that they need. And when we add in mycorrhizal fungi, tends to help the plants do that even better. And, just grow in really crappy soils, like the toxic soils found on contaminated sites. So yeah, it's a system, right, where we're actually working with plants, fungi, multiple types of fungi, where there's bacteria and worms and stuff. They tend to come in on their own as soon as there's stuff they can eat, right? So yeah, it's more of a system approach. But I tend to highlight the fungi because without highlighting them, they just aren't there. People don't put them in and then say that bioremediation doesn't work, but it's, I don't agree. I don't agree that it doesn't work. I think it's just that folks didn't know about the potential of fungi and how important it is for certain types of contaminants.
Yeah. Well, I mean, I think it's just to sort of hammer home the absurdity of needing to use a proven method, but not being given the space to test out if a method would provably be able to be used in a future. So the examples you just gave, are those from your own research? And if so, could you elaborate? And also, are there other examples from your own research to share with folks what the potential might look like?
Yes, yeah. So those methods are from my own research that I've been testing for over a decade in all these different types of projects, but most recently in this big project on contaminated sites in LA. So we worked with mycorrhizal fungi, decomposer fungi, native plants, and and tested that in these very real conditions here, with and without irrigation, and comparing these intentional introduction of known species we wanted to test for remediation, and then compared that with just stimulating what's already on site, including seeds in the soil, so plants and fungi and so on. And I've tested that this type of thing also in a lot of waste treatment systems. And I'm always working with cycles that we see in nature. So I'm always progressing from starting with a decomposer fungus. That's, again, those first ones that can break down stuff nothing else can. You start to have soil be created. The job probably isn't fully done, but now bacteria, you can work with composting systems, worms, and then plants can come in. And yeah, so this is sort of a system that I've been testing in all kinds of different scenarios with literally every like pollutant or waste that I can learn about. So, yeah, I'd be happy to share, everything from like cigarette butts to diapers to rivers polluted by industrial agriculture to, again, like large, highly contaminated sites to agricultural sites and beyond. So just been testing this system in a, as many different types of contexts as I can.
I want to talk about what you see the constraints of mycoremediation being. Mycoremediation in particular, but of course, eco-remediation. But right before we do that, if you could kind of say in a few sentences, like, what do you think, like when you reference people being skeptical, like what's the thing you say to them? What's the like potential you point to, or what's the line you say to try to change their thinking about it?
To address people's skepticism about mycoremediation, I will point to what I've seen with my own eyes happen, and not just once, but again and again over the years. I've seen amazing things about the potential of mycoremediation. So I've seen contaminated sites that when you walk in, it looks like Mordor or something, like truly devastated landscapes that are so contaminated that the soil is black with like oil. You can smell the oil. Sites that catch fire on hot days because of the chemicals in the soil, where there's not a single plant or worm or, like sites where I had to rent hammer drills to even like dig in the soil. So I'm just trying to paint a picture, right, of the extent of these sort of devastated landscapes that I've witnessed in a very, very short time with relatively low inputs, right? So where we apply some fungal mycelium, a bit of water perhaps, maybe some wood chips that are free from the city's waste stream. And, within 3 months, over 50% of the organic contaminants in the soil are gone. But it's not just that. It's that now there's plants growing where they couldn't grow before. That means there's worms coming in. The soil is supporting life. There's flowers growing. Now there's birds and bees. And it's just so beautiful and inspiring to see the type of transformation and cleanup and repair and regeneration that can happen in such a short time with relatively few inputs. And on top of that once you put in those inputs, that bit of work at the beginning, nature tends to take over and the regeneration just keeps happening. So the site that we'll hopefully get to visit, for example, but it's not just this site, it's any of the sites I've worked on. Once we've meticulously harvested everything that we put in so we can test it, going back months later, a year later, typically these sites are now thriving habitats so the regeneration just continues on its own. And that is something that I like to share those stories with skeptics about. One is just starting with some data. Like, okay, well, I've seen amazing degradation and cleanup happen in very short time periods with very little inputs. When mimicking nature, when you have a plan that mimics nature, I've seen amazing things. And so leading with data and then also sharing the qualitative piece, the story is what and it is what, well, it depends on the person, right? But typically a combination of data and like painting a picture or like a nice story can help. So I typically, but I always include the piece about time and inputs because a lot of skeptics think that bioremediation in general, whether with plants, fungi, bacteria, takes too long. And so, and isn't effective. So those are some really common things that I hear from skeptics. And so I really like to bring in the piece around like, well, I've seen it be effective, not just once, but again and again. And it doesn't take that as long as people say. And in any case, that's a sort of false notion anyways, because like again, 1/10 of California landmass is contaminated at least. There's contaminated sites everywhere that are sitting not being cleaned up because conventional remediation is too expensive and isn't feasible to address the scale of the problem. So it complicates this idea of like how long it actually takes using conventional methods versus these methods. I don't think 3 months or a year is actually very long.
No, it sounds kind of miraculous.
Right?
It seems like that would be probably cheaper than other methods, but maybe,
so much cheaper.
Yeah.
So much cheaper. That it's like, I mean, you can find like papers saying that it's 50 to 90% cheaper to utilize bioremediation. So there's just much data out there about mycoremediation or these methods that work with plants, fungi, and bacteria all together. But yeah, it's a lot cheaper, and it also can provide work for people too. So there's a whole potential for like workforce development connected to this as well.
That's a really cool idea. What just can you give a sense of what the workforce development like would look like?
Yeah, actually, we launched a bioremediation workforce development program a few years ago in LA. It started with the high school next to the largest contaminated site in my study. And now it's expanded to anyone in an LA high school can join in the program. And we get them there, has what the certification that they would need to work in this field, plus train them, plus give them hands-on experience. And they end up with a certificate in bioremediation. And so to be able to, for these methods to be applied at the scale of the problem, we need a workforce, right? We need people who are trained in these methods to be able to help implement. So yeah, that's kind of a notion of something we've already gotten started on, and where it could continue to go. And again, it's I think a really beautiful component to this work is that with contaminated sites everywhere, it means that people living near these sites have been exposed for a long time to the contaminants that blow off these sites. So typically, remediation is done by often like international engineering firms that do not have a connection to the place that they come in and do this work. So I just think it would be amazing for local economies to actually be able to employ people in these communities to help in the cleanup of their community. So that's kind of the thinking with the workforce development piece. And yeah, just creating more jobs that are sort of meaningful, regenerative, like creating an economy of regeneration, cleaning up the land. And we haven't even talked about connections to climate change, but pollution is all, it's like, well, yeah, it's just, the conventional remediation method is called dig and dump. It is exactly how it sounds. It involves digging up all the contaminated soil and dumping it out of state. So in California,
Wow.
contaminated soil goes to Utah, typically, or Nevada or Arizona. You can just imagine the emissions with trucks, like all this machinery loading trucks full of soil and all these trucks going across state lines. So there's a lot of emission. I actually saw a recent report that said that contaminated soil is actually California's #1 top export.
Oh my
And
God.
and it is the single largest thing ending up in landfills. So again, it just speaks to this massive problem that for some reason isn't like really talked about, or like I was like, what? Okay, so this is this state's biggest export and largest waste stream. And that's not even looking at the emissions. I don't know if people have looked at that actually, but it's a huge, if it's the biggest waste stream and the biggest export, it's going to be producing a lot of emissions. So there's a lot of linkages here. And in addition to that, if we could, get a workforce going locally to clean up these sites in ways that take away that need to remove soil and ship it out of state, clean the soil in place. We build soil that can support trees, the original carbon sink technology, right? Yeah, then like there's so many possible benefits, as well as like, yeah, all these other things I haven't even mentioned, like the potential to create biofuel out of the plant biomass that, once you remove the metals, and so many other ideas. So there's a lot of potential here for, I think, because of the scale of the problem. Actually thinking of that Lauren Bond quote now, right? It was like artists need to create at the scale that society destroys, or something like that.
Yeah, something like
but
that.
yeah, it just, I'm like, yeah, we need to do that. We need this. The scale of this problem is so big, and it means that like our solutions, if I can say, I know some people don't like that term, but how we try to solve that problem together, I think needs to be at that scale. So then it needs to think systemically about how this could actually be implemented in good ways that create jobs, that really just make such a compelling like case that it has to happen.
Well, what I appreciate about what you're describing, particularly the workforce development stuff, I mean, I appreciate so much about what you're saying, but in this particular context, there's a misconception when people are tasked with like thinking systems, and they think what that means is I have to change the system from the top down. But actually, like what that means theoretically is you change one node and the rest of the system is going to start to change because that one node has changed. And there's a way that we can, that messaging gets weaponized against people, like, well, you better recycle. Like if you were recycling, so that way of thinking can get weaponized. But what you're describing, for instance, with the workforce development this is small scale, this isn't like we are implementing the workforce development, mandatory across the nation. It's something that can be adapted from place to place and fit to the local ecology.
Yes, thank you so much for framing it in that way. That's exactly how I think of it. And that's why when I talk about my work, we bring, again, the fungi as like a point of connection, but then I always link it back to, I don't like to tell, people always want me to tell them like which fungi, which plants. And I don't like to do that. And the reason is, like we were just talking about, I really think of things as systems that need to be adapted locally. So talk about like, well, generally here's the components of a remediation, like an eco-remediation system that you would want to consider. But I don't like to say, okay, so you put in the oyster mushroom and then you put in, the telegraph weed, and then you put it, it's like, no. You put in a decomposer fungus, probably, and then you probably add in, some seeds for native plants that have the capacity to pull up the metals that might be present, and then you want to make sure the mycorrhizae are there because they help the plants. But yeah, I think it's really important to frame things as systems where you want to consider certain players or certain components. And I really think I really believe that way of thinking, and that it doesn't need to be top down. It can be literally from the soil up, right? And from communities up, can work and can really help us as we move through these really troubling times. And I like it as sort of a resistance to the Cartesian worldview that like the world is a machine and you just can plug in, you can plug in the oyster mushroom.
Dig up the soil, dump it somewhere else.
You dig up the soil, you dump it. It's just you can move around, pieces of the machine. If something's missing, you can plug it in and it's all good. And it's like, no, I think, I really believe we need to, I don't want to tell people what to, I think it's important to switch the frame on how we do this work. Yeah.
I mean, broadly speaking, I agree with you. And the case you're making is very compelling. You brought up the sort of people side to this in that past comment in particular, and with DIY fungi, you've been working with people on this stuff for 15 years. How do you see the work with fungi and the work with people relating to each other?
I love this. You have great questions. Okay, so yeah, and I appreciate you just clearly state the people piece, because usually when I define remediation or bioremediation, I include us in that. I'm like, yeah, you have to work with people on this stuff. We're biological too. So yeah, with DIY fungi, I was doing a lot of work actually growing fungi and teaching people how to work with fungi, grow them for food and medicine, for their garden health, soil health, remediation, and so on. And I learned a lot through that process of essentially like being a mycelium spreading human. I don't know. But it taught me a lot. And so the way that I approach working with people and working with fungi is the same, to be totally honest. And whenever I'm teaching people about whether it's like how to grow mushrooms or how to work with fungi to clean up soil or waste, I recommend thinking about it as relationship building. So approaching like working with fungi I approach working with fungi the same way I would approach working with people. So, you meet a new person, you want to collaborate, you're going to want to get to know who they are, how they live, how they thrive, what they need, and how you can support or offer something to build some type of reciprocity, right, in the relationship. That's how I approach collaboration as, relationship building. And then also typically, and this is where kind of science comes in too, but typically there's a process of hopefully, observation and feedback, right? So you're learning as you go and adapting. Oh, this worked. I didn't like that. Actually, that doesn't work for me. So so really approaching, working with fungi and working with people from an open place of learning, wanting to build reciprocity, offering something, not just taking or extracting. And actually showing up to care and to support and offer something that's needed. So, and with curiosity, of course, too, right? Not assuming that but being curious and being open. So with non-human life forms, that looks a little different, right? But it looks more like maybe observation but also just learning about, right? So, and this actually gets into some of what I think has made people skeptical about mycoremediation is that some of the early efforts didn't consider what the fungus needed. See, it's such a basic thing, but, and I've seen this again and again over time. If you don't consider what a fungus needs, you're like, okay, this fungus typically lives in a tree, in a like wet place. But like if you take that fungus and drop it into the ocean, it's probably not going to have what it needs, right? So yeah. Or if you if you have a fungus that needs oxygen and then you put it in an anaerobic environment without oxygen, it's probably not going to do very well, right? So it's like this kind of simple, approaching it like a relationship. What do you need? Get curious, offer that, offer that actual support. Then things tend to go quite well. And always So that's how I approach working with fungi, working with people, like building as you would build any relationship.
So you also referenced how this kind of this Cartesian dualism, and how it informs the way that we're inclined to think about, problem solution. It occurs to me also that, that being this kind of core driver of what we now call modernity in the West, and science is baked directly into that. Like the scientific method is baked directly into that. So you're working as a scientist and you've learned to do science in the Western tradition, but then you're also approaching it in this more mycological, ecological, some might say non-Western. There's something non-Western or non-modern way that I'm maybe editorializing, but it seems to me that there's a way that working with fungi has a sort of decentralized, non-monolithic, non-Western way of enacting itself. How do you square those two aspects of your identity and your background?
Not easily. Yeah, it's even just how the first question was who are you? What do you do? And I was like, oh no, I don't know. It's really hard to fit, to sum up. And that's the case too here. Yeah, I think I've always been a scientist actually, but I'm not, the funny thing is that science, I think, has become and has been so dogmatic. It's sort of like a dogma or an ideology. But people don't like to admit that. It's no, it's a system, it's a set of tools. And it is. And I think so the way that I'm a scientist is that I apply the tools of science. So I apply, creating hypotheses, testing them, making observations, gathering data and trying to do so, I guess, in a objective way. But that notion of objectivity, I think, is very complicated and sort of inaccurate. And it has always disturbed me, getting into these really hard sciences, right? Environmental toxicology. It disturbed me that we weren't also considering our worldview and how how the way we see the world shapes the way we interpret data and do science. So I think that science is, academic, I guess, Western science is starting to recognize the importance of interdisciplinary work and collaborations and even more applied research. But yeah, it's been a little challenging and a little complicated. I do think also there's as is widely discussed, right? Science can be things can be so siloed. It's what are you, a historian? Are you an artist or are you a scientist? Which is it? And that's really limiting, especially when what we're studying or researching is not that way at all. Nature is not that way. Fungi aren't that way. Even contaminated land isn't that way. So when I am a mycologist that studied in a soil science, like soil biogeochemistry lab in an environmental toxicology program. Like even that starts to get really complex really, really fast. And I'm really comfortable with that. I'm really comfortable with complexity. I'm way more comfortable with complexity than reductionist, like trying to simplify things. And it's just, I think, again, from, even as a child growing up and just seeing, seeing polluted and sort of damaged lands and waters and how they heal themselves in a sense. So I'm sort of, I think I'm rambling with trying to answer this question. It's not an easy thing to do. And I think in going to grad school in environmental toxicology, in a sense, I was trying to learn the language of science so that I could communicate effectively with scientists, policymakers, and now that I'm sort of, I feel like I learned the language enough that I can now start to critique and challenge and complicate things a little better than when I was like, someone without that ability to fully, speak the language. But I definitely draw on the tools of science and try to be rigorous and try to speak the language as needed to be able to actually communicate and actually be more comfortable with complexifying things.
There's a where my brain's going is a kind of like, there's almost like this oscillation where it's like you have to observe and recognize how reducing can help your mind get to the next step, but not so much that it actually sort of overtakes how you think about everything. Like you have to reduce in order to come back to thinking ecologically and kind of be doing that as you go. Because if you only are ever approaching things ecologically, it's too vast. Any system is too vast for your brain to comprehend.
Yep.
You have to kind of go in like piece by piece. And it's cool that the piece that you're kind of going in on as a baseline start point is the kind of like great connector within that, within that ecosystem.
Yeah, there's a lot of metaphors there. I do think I've approached all this work in a very mycorrhizal way, like building. Yeah, and again, it goes back to like what I even stated as my approach. It's like, which is you have to simplify enough to focus on a relationship at a time, right? So you can learn about it and then understand how that connects into the bigger system of relationships. Or the web of relationships. There's actually a funny piece that I think was really helpful. The first workshop I ever gave on mushrooms was to 3-year-olds. And I think it was really helpful because I had prepared a workshop targeting it towards adults and then got there and it was 3-year-olds. And I just threw all my materials over my shoulder and I was like, okay, how can I simplify this enough to communicate to people who are just learning how to speak, And it was amazing. I think that being my first experience communicating about fungi was fantastic because it helped me figure out how to simplify without losing the truth in a sense, or the, how to simplify without losing the truth. And that's really important in science communication. It's really important in communication. And it's really hard to do, how to simplify things that are incredibly complex enough so that people can understand and then reintroduce the complexity or link it to bigger systems.
Yeah. Well, and you also have a background as an artist. So there's something there too.
Yeah. Yeah. And I'm trying to, now that I'm not only toiling in the lab like all the time, I'm excited to bridge these worlds again. Yeah.
Talk to me a little bit about how that arts background and your background as, a historian, like how do those backgrounds sit with, your current like proper professional hat?
With the arts piece, I think they connect in because I just always have liked doing things with my hands. I like making things. I like being hands-on. And then I also like thinking conceptually, or maybe not like, I'm just sort of, same with the historical, like social sciences piece. That's lent me sort of this ability to, I guess, like think about larger systems, not just ecological systems, but how social systems intersect and are, and economic systems and things like that. So to me, they're all, I mean, I tend to see things as all very connected and think very systemically anyways, but certainly like the history degree helped me understand how did we get here and what are likely futures based on what we've seen in the past. And then how can we learn from the past as we go into these new sort of ages of, again, like troubled times. So yeah. And then I think the arts are really important in terms of, I think, well, in a lot of ways, in terms of like reminding people of beauty sometimes, or just helping us look at things, helping sort of like frame, like put something in our view so that we can look at it and appreciate it, as well as like helping with that storytelling piece. So I think, yeah, to me, these fields are all connected and or potentially very connected, and we can learn a lot from each other.
I think you've made an incredibly compelling case for why people should consider mycoremediation and thinking ecologically about, whatever land they happen to be on. But one piece that we started, but then kind of went, we sort of rhizomatically moved away from was those constraints, like what mycoremediation is not necessarily good for, or places that we maybe don't have enough research, or just like ways that you temper the inclination to start to think of it as like a silver bullet, like, it'll just sprinkle some mycoremediation on, and then, so yeah, like what are, frame the constraints for the audience.
Thank you. Yes, it's so important. Mycoremediation is not the solution to everything. It's not applicable in every on every site, for every waste. It's just not going to solve everything. And there's a lot of constraints. There's still so much more to learn. Like I said, there's very few field studies that have been done. So there's a ton to still learn as we try to scale and test mycoremediation in different scenarios on different lands and different climates, and figure out how to scale it. A major constraint in there, if you're working with the approach of introducing like a fungus that you think will eat diesel or whatever it is, you got to have a lot of mycelium, right? And so in my work, I've worked with spent blocks from mushroom farms. So that's a waste stream that you can produce in huge amounts that you can typically work with. But if you don't have access to those, you've got to find a way to produce a ton, like literal tons of mycelium. So that's a constraint. Again, if you're working with that approach as compared to the just supporting the fungi that are already there, you're probably going to need to figure out how to get water in there, support their lives, which it maybe sounds straightforward. Take my word for it, it's not straightforward. It's really, really hard to get enough water to like a large contaminated site in a droughted region, for example. So that's just one example. There's a ton of constraints. There's regulatory constraints, as I mentioned, which we're working on. It's there's a lot of constraints. We hardly know anything about this, and there's so much more to learn. And it's just not going to be applicable everywhere. Sometimes, I've seen projects where people are like super stoked on fungi, so they're like, we want to do mycoremediation, but it's just not a scenario. Like if you have only metals, right? So you have a site that's contaminated with lead, fungi might not be the best option there. Probably plants are going to be
Mm,
better
mm,
at actually removing those metals from the soil. Or you can apply minerals that'll bind up the lead in the soil. You see what I mean? So it's
mm,
like it's letting the excitement lead to curiosity rather than just assuming that we could just put fungi in and they'll deal with it. Um, and then the other thing I like to say here too, bringing again back the importance of people in bioremediation, is just that I don't think it's fair to sort of offload our responsibility onto this other life form, right? And just, I also think it's dangerous because you can't assume that if you put, a mushroom block into some soil that it's now cleaned up and
mm,
solved the problem.
mm,
You're going to need to actually test to see what's going on with the contaminants and have they been reduced and so on. Um, so yeah, I definitely appreciate the question about the constraints. There's a ton we still don't know. There's a ton of regulatory limitations on even testing these methods in the real world. And yeah, I mean, again, like there's a lot of contamination in the ocean or in, the bottom of a landfill, and it's going to be hard. You've got to consider that the bottom of landfill is not a place with oxygen. So, in the ocean, you're going to want to work with probably like fungi that live in the ocean or get the pollution out of the ocean into something that fungi can work with. So, yeah, there's
mm.
still so much to learn. There's a lot of constraints that really need to be considered, and also, yeah, I think it's really promising, and it's definitely worth it to keep exploring mycoremediation and to keep training people so that we can apply these methods and keep testing together. Yeah, and at the same time, just yeah, fungi. A lot of the projects I've worked on, we didn't get 100% cleanup. We've got to keep going. We're at the
Mm.
beginning. It's really promising, but there's still a lot more to figure out until like before this technology, I guess, could be applied more broadly.
Mm. It seems to me that regulatory piece you brought up is really critical. Like I think about Jevons paradox, like the idea that any efficiency gain we make with a new technology or new energy source, then oftentimes what happens is industry steps in and fills that whatever gains that were made in efficiency then are sort of gobbled up because the system, the human system adapts and says, oh great, it's more efficient, like let's use more. And it seems that for as amazing of a thing as mycoremediation could be, it could fall into the same trap of like, oh, let's just pollute more because now we have this amazing way of remediating absolving ourselves of the sort of guilt we might feel. And so it almost seems to me that regulatory piece is kind of an anchor of sorts to hold certain aspects of human nature in check when thinking about a solution like this. How are you, like you've brought it up a few times, but I want to kind of zoom in on that. How are you, like you've had several years of interacting directly with regulators and policymakers, and I don't know if in your current work you still are, but I'd love to hear what that's like and insights you've sort of gathered along the way.
Yeah, I still am connected with regulatory agencies. I serve on an advisory council for remediation technology with the Department of Toxic Substances Control, and it's an honor to be able to sit on that advisory and learn and also offer information, I guess, about these alternative approaches and try to keep pushing for the potential to apply them. But I completely agree, and it's in terms of what I don't want to see is more pollution because we're developing nature-based remediation methods. So as I work on this in this field, I try to, as much as possible, frame things in those way, keep working on the policy pieces, and try to keep the, I guess, knowledge and methods accessible to not just companies, but to, again, communities, getting the knowledge into communities and the training and into sort of local businesses and groups and institutions. So I don't really know how to solve that problem other than speaking out, like offering what I know, sharing what I know with communities that are impacted, and serving on these regulatory advisories and things like that, and trying to support policy efforts that also protect land and people. So, for example, another way that paradox I think can come into play is that as a site gets cleaned up, then it has now can potentially be developed and I don't know, repolluted or whatever. So I don't know. Yeah, I don't know how to solve that problem. I'm really open to collaboration with groups that are, and I'm very honored to have learned from communities that have been, working on these pieces and been alerting me to, for example, like, what's that called? Like different policies that need to be part of this work to protect land and people so that it doesn't just enable further pollution and destruction. And so one example would be just I'm forgetting what it's called right now, but essentially anti-gentrification policy to protect renters in areas that are getting remediated, so that once this contaminated site that's been a blight in a neighborhood for decades is cleaned up, it doesn't get redeveloped in a way that pushes people out of the community, things like that.
Yeah, I don't have the expertise you have in this issue. My general sense with a lot of the sort of major facets of the poly crisis, particularly as it relates to climate and the relationship of climate and economy, is regulation. We just desperately need strong regulation, and it's so hard because of all the regulatory capture that you come to, like, you either come to find out by, like, you directly find out who the funders are or who sits at the top of those regulatory agencies, or you start to realize, like, oh, there's places that those regulatory agencies aren't looking that they definitely should be looking. And so, I mean, I think subject matter experts like you play a critical role in kind of banging that drum on those advisory councils of, like, we have to be focusing on this, we have to be regulating this.
Yeah, it's a great point. And I am trying to get publications out too, like white papers, like presenting, framing the problem and then presenting policy alternatives and really advocating for those, and making sure I also am, like, connected to people who are affected and all these different, I guess, stakeholder groups, so that their, voice, so that the policy changes that I might be advising are on point, because I totally agree. The regulation part is so important. And then it's so interesting being on these advisories and regulators are like, we have no power. Our hands are tied. It's like, what? No, come on. But I will say that community, like the public actually does have power. I think we don't know that we do, but actually, like, it does matter if there's enough pushback and enough feedback, then it is meaningful. I keep hearing that being in these advisories and stuff. They're like, okay, well, everyone's mad because we gotta. So it does do something. Yeah, I agree with you too about the regulatory piece.
It also gets at this. I mean, obviously, like, really, in most cases, what we're talking about in regulation, sure, we might be talking about think about the EPA, like you're sort of regulating. What you're actually talking about is industry and economy.
Yeah.
And mycelium is fascinating to me, thinking with my like poet artist hat on, in the way that it's embodying a certain type of economy. And I know that you use this term moral economy. So I'd love to kind of zoom in on that for a moment.
Yeah. So moral economy, the concept and the term moral economy comes from James C. Scott. He's a historian. So I learned about this concept in my history degree from a book called The Moral Economy of the Peasant. But it gets into this economy that can be in existence, this sort of invisible economy that actually is so much importance and so much power. And that's this economy of essentially like mutual aid and of community. And so it draws on examples throughout history of specific peasant communities that you might think of as having no power or very little power, but actually that within these peasant moral economies, like before the advent of capitalism, that actually so this is again from this book, but that individuals didn't starve. So if there was famine, communities would starve together rather than and that's because of the moral economy that glued people together into these networks where they knew that they relied on one another. So everyone goes hungry instead of a few individuals starving. And under capitalist economic models, individuals starve, right? And it's that whole everything about it is this individualistic notion, right? You got to pull yourself up by your bootstraps, like kind of idea. You got to take care of yourself in like rough conditions, right? And I love the concept of the moral economy. And it ties into, I think, fungi as metaphor and like actually where fungi tend to exist in these networks, these webs, which could sort of be described in similar terms. It's hard to even pick out or decide who an individual is in a fungal network. So, I love that concept of moral economy and how it ties into concepts of like how do we get by together in like as capitalism is failing.
Yeah.
It's not working great. In my opinion. Working great for some people.
Yeah, a small number of people it's working tremendously well for.
Small number of people it's working great. But the rest of us, yeah.
All right, well, I'm sitting here with a mycologist. I think I would be remiss to not ask if you've had any surprising or illuminating experiences with mushrooms of any kind. Because obviously you've worked with many different fungi.
Oh yeah, so many. I don't know almost how to pick, but yeah, I think some surprising experiences. I mean, especially as like, I started out as a very DIY, like amateur, like built a lab out of garbage, grew mushrooms on garbage for a long time. And I think it truly surprised me how resilient fungi are and how adaptable they are. I think I had this notion that you had to, have a science degree or like a fancy lab and a ton of equipment to be able to like work with fungi and grow them. And it just really was a delightful surprise that was not the case. You can grow like fungi in like, your sandwich. Like I would literally like eat my sandwich and then like put some spent coffee grounds in the bag that I took my sandwich out of and like put a little mushroom in there and like grow mushrooms. So it's, I think I was delighted by how resilient they are, how adaptable, and just how many different environments things they could grow on was a delightful surprise. Yeah, I don't know how much to share, like weird
as
weird
much as you want.
surprises.
Weird
Okay,
as much
I'll
as you want.
just
Yeah.
own it because history of science. Like people learn things from dreams. Like for real, a lot of advancements have been made by a scientist having a dream or an intuition or something, and that's happened for me too with fungi. Where when I first started working with fungi, I dreamt about them all the time, and like they would. This sounds really kooky, but I would learn a lot from dreams. Sometimes really specific things, like I would be working on a particular remediation project. I was working on one of agricultural runoff water, and I remember having a dream where I think it was turkey tail. People might know that mushroom, but yeah, I had a dream about like turkey tail, and turkey tail was like, "Hey, we can." We'd be happy to degrade like organophosphates. Hey, you should try that. We could do that. We can do that for sure. So, stuff like that was kind of a neat surprise too. Just that this sort of intuitive and potential to learn from fungi too.
I love that. Yeah, I mean, we understand so little about dreams that it would be foolish to foreclose on the idea that the spores we breathe in, the smells we smell, the foods we taste, that those don't interact with our dreams because we understand them so little.
Right? Yeah. Yeah. And I think even just like in a very logical way, there's so much information that we're taking in that we're not conscious of because it's not relevant immediately to our survival, but doesn't mean it's not going into our memory and maybe being processed and coming out in dreams too. That's like the most logical explanation, but it doesn't need to be that way. It might need to be that way for some people, but
yeah, I like it. You can hold open that there's a scientific justification, that there's possibly a mystical justification, but that maybe could be justified by science. Who knows? But point being, it led you to some great scientific revelations. I have 3 recurring questions that I like to do with every guest. The first of which is, what is one resource you use to make sense of reality?
One resource I use to make sense of reality is dreams, actually, and intuition. Yeah.
Wait, say more about the intuition part too. Like,
okay.
How do those fit together for you?
I've learned to kind of differentiate between different types of, I guess, feelings or intuition or like gut feelings, and same with dreams. And there's this certain kind of flavor of intuition that I really trust now. And this is like vulnerable to share in a way, but like, for example, I've followed this intuitive hit to select the species combinations that we'd be working with for a particular site before having the data back. And, that's risky, but when I got the data back, I trusted my intuitive hit. And when I got the data back, it was exactly what I had, I guess, hypothesized or intuited or however you want to put it. And so, you could say that that's come from, I've been working on this stuff for many years. I've been on many a contaminated site. And so maybe there was a aspect of just sort of like learning and pattern recognition over time. But also just like that intuition or whatever you call it, pattern recognition or experience or whatever, really saves time if I trust it, right? It and it has led to some surprising some discoveries that then we can then, further test and back up scientifically. But that's a resource for sure. There's another thing I really like to share in case it's supportive or inspiring for people, which again is like another resource is each other, like our collectivity, and just the huge amount of garbage everywhere. You know, I just like to say that because, like, again, you don't need to, if folks are wanting to get involved or like do some of this stuff, please be safe. Don't work with toxic stuff if you don't, without protective gear and stuff. But yeah, like I started a lab without any money, like just by salvaging stuff from like the side of the road and the land, like waste is an immense resource. Like we are wealthy with garbage. And I think that's a resource that is really important to mention because I think without seeing like all these resources that don't cost money, we can feel really limited, right? In our potential to take action or realize a project or do something. And yeah, so I like the question. I think it's really important to notice resources, all the resources we have. Yeah.
Well, I mean, the next question, actually, I mean, in a sense you answered it, but I'll ask it to you anyway in case it prompts another thing, which is what's one thing you wish people paid more attention to?
It's kind of a cheeky thing to say, but I wish people paid more attention to the things we don't want to pay attention to. The garbage, the out of sight, out of mind, the darkness, the underground, all the things that we, the toxicity, not in a way, I don't want people to be overwhelmed. I don't want people to be despairing, but I do think that we need to look at things so that we can face them together, And so, and I say that I wouldn't say I want people to look at toxicity if I didn't believe that there's a lot that we can do about it.
It reminds me like when when the bank account's low and that, but you don't want to look at the bank account to like confirm for you, but it doesn't change the fact that you're broke or whatever.
Exactly.
So yeah, like how do you just, I'm adding this question in, like when you're, cause there's a lot of like optimism and hope in your work, even if what it's taking as base, like we're going to toxic waste sites. But there's a lot of optimism and hope of saying like, there's a way of not only like solving this problem, but actually like restoring this ecosystem to what it like aspirationally wants to be just, in normal times. Like, how do you talk about that with people?
I think it's really helpful often for people to see something that's already working and happening. And I think sometimes people need that first to be able to then face the rest of it. So whether like, it's really hard to be able to bring people to toxic sites, but whether, through pictures or film or storytelling, setting the scene, telling the story, that's how I try to. And I always, and I've learned this from experience, like it's overwhelming. People, it's a lot easier to deny things when you don't feel like there's anything that can be done or that you can do or that we can do, right? It's just too overwhelming to then learn about horrible problems and then just feel overwhelmed and like there's nothing that can be done. So I always am careful to present my experience seeing that, yes, there is something that we can do. Like there is something you could do, I could do. There's something we can do together. It's not going to probably save the world. It might help though. It might help. And I would rather try than not try, but yeah, just presenting again, like, a story of there's something we can do and here's the problem, like presenting those together, I find really helps. Yeah.
Well, and what I love about how you've approached your work is like, you really are sharing, it's not examples of like what the what the royal we could do. You're saying, no, like the we of the us, the human beings sitting right in front of each other. Like we could go do this right now with appropriate reading and training and don't go into toxic waste sites without protective gear.
Seriously, please don't. But talk to me if you want to get, involved.
Right. Danielle's got you on how to stay protected in a toxic waste site. finally, what is one moment in which your sense of reality was disrupted?
So the first thing that comes to mind is actually the first time I saw mushrooms. They were shaggy mane mushrooms, and they were like forming a ring around a oil tank, like a huge oil tank, an abandoned oil refinery. And I think that disrupted my sense of reality because I was like, what? How can these little fragile mushrooms that are going to dissolve into ink tomorrow have busted up through this like ashfall and like growing in this toxic wasteland? And so it sort of disrupted my sense of reality in the most beautiful way, right? In terms of like opening possibility for healing. In ways that just seem impossible, right? And that's what I mean. That kind of gets back into like, that hope piece. Like it just, how can these like fragile little mushrooms like actually break through ashfall and eat it? It's amazing. So yeah, that's the story I think I'll share for now about a moment that disrupted my sense of reality. Yeah.
I love that. It's very, speaking of the artist in you, like there's such a powerful metaphor in that.
Yeah.
Can you tell us a little bit about what you're working on now?
Yeah. So what I'm working on now is research into fungi that can eat plastic. And that's super exciting. So the goal with that is to work on landfill specifically. But obviously plastic is a huge environmental problem right now.
Oh, I hadn't heard.
You didn't? What? Okay. Yeah. Well, for those listening, that's the thing. Plastic is everywhere. It doesn't break down for like hundreds of years. So yeah, we're trying to speed that up with fungi. So I'm working with a company in Austin right now.
Amazing.
Yeah.
Well, I can't wait to hear more. Thank you so much for being on Urgent Futures. Where can people find you if they want to follow up and learn more?
Please follow up. Yeah, I love that. You can find me online, DanielleStevenson.com. My contact info is on there. I try to keep it updated with projects and, press and videos and stuff where people can learn more. That's probably the best place.
Amazing.
Yeah.
Thank you again so much.
My pleasure. Thanks for having me.
This podcast is edited and produced by Adam Labrie and me, Jesse Damiani. The podcast is presented by Reality Studies. You can learn more by visiting realitystudies.co. And if you appreciate the work I'm doing, please subscribe and share it with someone you think would enjoy it.